are the effects of changing the values of ABC on graphs of quadratic functions? Fx equal to ax squared plus bx plus c. My stimulation. The aim of this activity is to identify the effect of changing the values of a on graphs of quadratic function fx equal to ax squared plus bx plus c. So, today's learning standard is to investigate and make generalization about the effect of changing the values of A, B, and C on graphs of quadratic functions. Fx equal to ax squared plus bx plus c. Steps. First, drag the slider from left to right. Before that, you need to scan the QR code here. Scan the QR code to carry out this activity. It is at the website www.geogebra.org/nhxfjgy3. After you scan the QR code, you have to follow the steps. Drag the slider from left to right. This is the slider. And then you will observe if the A is 0.8, the curve is wider in terms of the shape. If the A is smaller, the shape of the quadratic function is wider, is open wider, whereby if the A is bigger, when you drag to the right, 3.2 is bigger number, the shape, the shape of the quadratic function will be narrow. The smaller, the bigger, the shape of the quadratic function, and the bigger the value of the A, which is a coefficient of the x squared, the narrow the shape of the quadratic function. So discussion. What are the effects of changing the values of A to the graph of quadratic function? So as I mentioned earlier, the effect is when the A is smaller, the shape of the quadratic function is opened up wider. When the A is bigger, the shape of the quadratic function is opened up narrower. So from the activity in my simulation 7, it is found that the values of A determines the shape of the graph. So let's see the interactive zone. Discuss the effect on the curve. Discuss the effect on the curve. Of the graph of quadratic function when A is less than 0. In general, for the graph of a quadratic function, fx equal to ax squared plus bx plus c, the smaller the value of A, the wider the curve shape of the graph, and vice versa. So this is a conclusion. Let's go through again. For A1 less than A2, you can observe that for A1, which is a smaller value, we have the shape in green color. For the A2, which is a bigger value, the shape is in purple color. It's narrow where the A is bigger. And the same apply for the A1 and A2 when the value of A is negative. So if the A1 is less than A2 in terms of the magnitude, this is the shape of the quadratic function is open up wider when the A1 is less than A2. Whereby for the A2, it is a value which is bigger than A1, the shape of the quadratic function is in purple color and it is narrower. It's open up narrower is an N shape because the A is negative, right? So let's see my stimulation number 8. To identify the effect of changing the B, values of B on the graph of quadratic function fx equal to ax squared plus bx plus c, you need to scan the QR code to carry out this activity. The activity is at the website www.graphing/vpzgvwba. So let's drag the slider from left to right. So as you can see, if you drag, you will notice that the position of the graph is actually shift to the right. Right. This is a A. This is a B equal to -2 here, and this one is okay. Let me figure out the value first. Observe the position of the axis of symmetry as the values of B changes. Axis of symmetry is the line that goes through the minimum point or maximum point of the quadratic function. Discussion. What are the effects of changing the values of B to the graph of quadratic functions? From the activity of my stimulation, it is found that the values of B determines the position of axis of symmetry. Position of axis of symmetry will be changed if the values of B change. In general, for the graph of a quadratic function fx equal to ax squared plus bx plus c, if a more than 0, b more than 0, the axis of symmetry lies on the left of the y-axis. If b less than 0, then the axis of symmetry lies on the right of the y-axis. If b equal to 0, the axis of symmetry is the y-axis. So let's study this one. When b is more than 0, so the axis of symmetry is to the left. It's actually at the negative side. When b is less than 0, the axis of symmetry will be at the right side of the y-axis. When b is equal to 0, the axis of symmetry is the y-axis itself, right? Okay, so it looks like very interesting. For b more than 0, for the N shape, when the a is negative, when a is less than 0, you will observe that b more than 0, the axis of symmetry lies on the right axis. Okay, b more than 0, the axis of symmetry lies on the right of the y-axis. For b less than 0, the axis of symmetry lies on the left of the y-axis. Left. When b less than 0, this one b more than 0 is at the right. It's totally opposite with just now. When a more than 0, right. So same thing, when b equal to 0, the axis of symmetry is on the y-axis here. This is the same we just now, is on the y-axis here, right? So this is the effect of the changing of the b for the quadratic function. Now for next activity, we are going to study the effect of changing the values of c. Okay, the effect of changing the value of c of the graph of quadratic function fx equal to ax squared plus bx plus c. First of all, you need to scan the QR code to carry out this activity. Have you scanned? So the QR code is at the https://www.geogebra.org/rv7njx84. So you need to drag the slider from left to right. When you drag from left to right, you will see the left is actually a smaller number and the right is a bigger number. So the graph is shifting upward if you drag from left to right. Observe the position of y-intercept of the value of c changes. So the y-intercept is a point of a graph that intersects the y-axis. So let's discuss what are the effects of changing the values of c to the graph of quadratic function fx equal to ax squared plus bx plus c. From the activity in my stimulation 9, it is found that the value of c determines the position of y-intercept. In general, for the graph of a quadratic function fx equal to ax squared plus bx plus c, the value of c determines the y-intercept of the graph. A less than 0, the end shape of the quadratic function, and this is the c. For a more than 0 is a U shape, and you can see c is the y-intercept. So this is the changing of the value of the y-intercept of c of the quadratic function. Let's have a look at the example 2. The quadratic function fx equal to x squared minus x plus c passes through a point A. As given below, calculate the value of c in each following cases. When A is 0, 4, the point 0, 4 lies on the y-axis. So hence, the c should be equal to 4. For B, negative 1, 3. So for this one, we need to substitute the value of x into the fx by substituting x negative 1 and fx equal to 3 into the quadratic function. And we can solve and find the c. It's very simple. So hence, the conclusion is c is a y-intercept of the quadratic function fx equal to ax squared plus bx plus c. Okay, so c is a y-intercept. So we will continue for the next subtopic for the audio book Mathematics Form 4. Till then, bye-bye and have a nice day.